6.3 linear relations continued. Make sure that for organizational sake you're writing in the date, and make sure for identification purposes you're writing your name. Mine's Tara. Before we move on in this unit, specifically kind of going from tables of values to equations, that can often be somewhat difficult, let's just take down some definitions. So a relation is a rule that relates two quantities. Now, as you take more math classes, you'll realize that sometimes relations can relate more than two quantities, but for the scope of this course, we're just going to focus on two. There's one definition that I actually forgot to write in, so let's write it in for me. Independent variable. Because remember, we're going to be dealing with two different variables, the dependent variable and the independent variable. Now, the independent variable is the variable, or a variable, that we choose the value for. So if we're talking about a taxi ride, we choose the number of kilometers and the equation at the end will spit out the cost. Or if we choose a figure number, say in the case of that worksheet that we did for the previous section, if we can choose the number, the figure number, and the equation will tell us how many toothpicks it takes to create that figure. Now, the dependent variable is the other one. It's the y usually in the equation, and that's a value or a variable whose value is determined by the independent variable. So in the case of, say, creating an equation for the cost of a taxi ride, the independent would be the number of kilometers driven, and the cost would be the dependent, because that's the value that gets spit out of the equation. And specifically a linear relation, okay, it's a relation that has data points which create a straight line. So if we were to create this plane here, we would see that this is an example of a linear relation, this is an example of a linear relation, but if I choose a different color, something like this is not an example of a linear relation. Okay, it's a relation that has data points which create a straight line. Okay, so here we get to the big times. Make an equation from the following chart of values. So we're seeing that this is going to be our independent, and I'm just going to shorten it down as indep. And we have our dependent, so I'm going to shorten it as dep. So first things first, we want to leave room for this zeroth term. It's kind of strange, but it really helps us figure out what the constant is going to be in our equation. Because oftentimes we're going to get, we're going to have the form y equals m, okay, some number, that can be some number x, plus b, which is some constant. So we're going to have the dependent variable, the independent variable, and then two numbers, the m being the coefficient and a b being a constant. So if we leave room for the zeroth term, that's going to help us determine, or it's going to tell us exactly what our b term is. So let's just write down some steps how to create an equation. Now, some of you can look at this chart already and say, oh, I know exactly what that equation is. And that's amazing. That's kind of a gift that I do not have. I like to follow the steps each time because it helps me out. So step number 1, we want to leave room for the zeroth term. And sometimes on tests I will leave a gap there so we can just to prompt you to do that. So I won't always do that though. Leave room for the zeroth term. And the zeroth term we can also just call the constant. Determine the pattern. So what I mean by determining the pattern, as I move one step down in the dependent, I am, in this case, subtracting 4. So for every plus 1 in the independent, I go down 4. Let's see if that's true in this case. 37 to 33, yes, minus 4. 33 to 29, yes, minus 4. 29 to 25, you bet, negative 4. 25 to 21, yeah, negative 4. So this is how we know that it's actually a linear relation, because it either goes down or goes up by the exact same amount. So for every plus 1 in the independent, we are going down 4 in the dependent. Step 3, determine the zeroth term, or the constant. Sometimes the constant is going to be 0, so you're not going to have a constant, but in this case we most certainly will. So if I go from this row to this row, if I go down one row, I have to subtract 4. But if I go up a row, if I go from 21 to 25, that means that I'm adding 4. So if I want to go from 21 to 25, up 1 I plus 4, or I add 4. 25 to 29 I add 4. That means if I want to go from the independent value of 1 to the independent value of 0, I'm going to subtract 1 in the independent, but what am I going to do? I'm going to add 4. So that means that this, the zeroth term, is going to be 45. Now, step number 4, this is how we can create our equation. So what we want to use is we want to use the variables that we've been given. This is our dependent. So I'm going to put Q equals, and then I'm going to say something, and our independent is G plus something. Now I'm just leaving blanks right now, and I'm going to use highlighters. I'm going to use the highlighting function here so that you can see where all of the variables come from. So our Q comes from our dependent, and our G comes from our independent variable, and always on the left hand side is going to be our independent, and always on the right hand side is going to be our dependent. Now this spot right here, the coefficient in front of the G, is going to come from where our pattern is. It's going to be, in this case, negative 4. Because for every plus 1 in independent, we go down 4. So if we have an independent variable of 5, we're going to go negative 4 times 5. It's going to be 20 less. And look at that. The difference between 25 and 45 is indeed 20. Now we get our constant term from the dependent of our zeroth term. So I'm going to say plus 45. Oh, I don't actually need to say plus because, oh, because I got it. Let me just grab this back. It's going to be positive 45. Now say this was negative 45, this sign right here would turn into a negative, but since it's positive, we just keep it at positive. And what you want to do actually is you can test it out. So pick a point. I'm going to pick 3. So if I put in for my independent or my G 3, I should be getting 33 for my dependent. So I'm going to say test point G equals 3. So then I say Q equals negative 4 times 3 plus 45. Q equals negative 12 plus 45. And guess what, folks? That is indeed Q equals 33. So I can use this equation here to plug into any value or plug any independent value into it, and I can confirm whether or not my equation is correct if I get the dependent variable.